Welcome back, students, to the Chemistry Unlocked classes. So, as was decided in the last class, that we'll be discussing the activities in the book. So, let's come back to activity 1.1. Now, let's see what is this activity about. So, physical nature of matter. Matter is made up of particles. So, activity 1.1 is the activity which decides or which proves that matter is made up of particles and it's not like a continuous block of wood, but it is made up of particles. Now, let's see what all things are required or what have we done in this activity. So, they have taken a 100 ml beaker and they have filled it with water. And when you add salt or when you add sugar, so where does it disappear? What do you think has happened to the salt? Where does it disappear? And does the level of water change? So we have seen in our life when we do this activity that the level of water does not change much. So what happened to the salt? So this is a proof that water is also having a particle nature and salt also has a particle nature. So that is why what happens is that suppose these are the water particles and when you put salt in it, let me take the color, say red. So the salt gets lodged between the particles of water. Understood? So that is why what happens is that the level of water does not change much because there's enough space between the particles of water. And this helped the scientists to figure out the nature of matter, that it is made up of particles and it is not a continuous like block. So suppose the matter was like continuous block. So if you were to add salt from the top, so what would have happened? What would have been the observation? That the level should have been increased. So that was not the case. So that is why it was proved that the matter is having a particle nature. Okay, so I hope this activity is clear to you all. Now let us go further. How are these particles? How small are these particles of matter? So this activity is proved with the help of potassium permanganate. So let me first explain to you what has been done. So they have started with, let's say, 100 ml of water. And when you put 2 or 3 crystals, or even say, let's say, 1 crystal of KMNO4, KMNO4 is purple in color. So let me show you, this is KMNO4, right? So when you put KMNO4, the water becomes purplish like this. So in this activity, what they have done is in 100 ml of water, when you put 1 speck of potassium permanganate, it becomes purple. Now they have, so purple means the particles of KMNO4 is purple, which makes the water purple. Now what they have done is that they have taken say 10 ml from this beaker, diluted it to 100 ml. Then 10 ml from this beaker, diluted it to 100 ml. So like this, if you go on doing the dilutions up to say 8 times or 9 times, you can still see a tinge of color of potassium permanganate. So you can see here it's written, keep diluting the solution like this to 5 or 8 times. Is the water still colored? So yes, it is colored. So this experiment helps us to prove that particles are very small in nature. So then what becomes the aim of this activity? To prove that particles of matter, be it solid, liquid or gas, it's very small. So this is what is activity 1.2, right? Now let's come to activity 1.3. Now, what is the heading or what's the title of this activity? Particles of matter are continuously moving. So even if you have solid particles like particles in solid, which are where the solid appears to be not moving. So if these are the particles of solid, Not they are not so close. They do have some spaces. So even if you have, say, these are the particles of, let's say, wood, right? So although the particles appear to be still, but they are not still, they are vibrating at their mean position. So even for solids, the particles keep moving. So what are we going to prove in activity 1.3? That particles of matter are continuously moving. So what has been done in this activity? So it's an incense stick activity. So incense stick or agarbatti, which we call. So if you say burn an agarbatti in one corner of your class or of your room, so what will happen is you will get the smell from far away. So this proves, or this helps us to prove, that particles of matter are continuously moving. So this is activity 1.3. There's one more activity, 1.4. Here it will find out that what happens to this movement with temperature. So let's see what is proved in activity 1.4. So take two glasses or beakers filled with water. Put a drop of blue or red ink slowly and carefully along the sides of first beaker, and honey in the same way. No, so this is not the effect of temperature, it's the effect of cut. Start. So activity 1.4 here talks about diffusion or intermixing of particles. So if they are moving, so they will automatically intermix without stirring. So in this activity, what they have done is they have taken two glasses filled with water. In one glass, they are putting red or blue ink slowly along the sides. And in the other beaker, they are putting honey. So we know that ink is more fluid, or it flows easily as compared to honey. Honey takes time because it's a thick liquid. Leave them undisturbed in your house, or in a corner of your class. So what would you observe? What do you observe immediately after adding the ink drop? So the ink drop spreads quickly. We have observed it. Spreads quickly. What do you observe immediately after adding a drop of honey? So because it's a thick liquid, so it spreads slowly. So let me write here, spreads slowly. How many hours or days does it take for the color of ink to spread evenly throughout the water? So almost we can say in half an hour, the ink mixes very well with water. So let's record these observations and go further. So there are three activities in a row. Activity 1.3, which proved that particles do move continuously. Activity 1.4, which is proving that for some liquids, for some matter, the particles are moving fast, and for others like honey, the particles take time. So it depends upon the nature of the matter or nature of the liquid. Similarly, activity 1.5. Now, what is this activity about? So, drop a crystal of copper sulfate or potassium permanganate. So, again, we came to this potassium permanganate activity into a glass of hot water and cold water. So, now this studies about the effect of temperature. So, you have taken hot water and cold water, effect of temperature. On, on what? On movement of particles. So all three activities are related to movement of particles, children, right? So in this, what happens is you put copper sulfate of potassium permanganate in hot water, and another uh, beaker or glass is containing cold water. Do not stir. This is the condition because we are studying the movement of the particles. So we don't have to move them manually. We have to see whether they move on their own or not. Allow the crystals to settle at the bottom. What do you observe just above the solid crystal in the glass? What happens as time passes? So what do you observe just above the solid crystal in the glass? So let us see over here. It's my opposite. So let's see this. So hot and cold, this is the same activity. in the image form. So what do you observe above the solid crystal? You see that the particles are moving, or it is forming a like a you can see that the color is mixing slowly with the water, right? What happens as the time passes? So more and more solid appears to be mixing with water. What does this suggest about the particles of solid and liquid? So it suggests that the particles intermix, which in technical language or chemistry language is called as diffusion. So the particles diffuse means to intermix with each other, even though you are not stirring it. Does the rate of mixing change with temperature? Or we can say, does the rate of diffusion change with temperature? So yes. Why and how? These are the two questions which we need to answer over here. Right. So why does it change with the temperature? So we know that the particles keep moving. With temperature, this kinetic energy of the particles increases. So that is why with temperature, the rate of mixing changes. And how again is because as more and more particles are moving with high speed, so what will happen is that the rate of mixing or diffusion will increase. So from the above three activities, 1.3, 1.4, and 1.1.5, we can conclude the following. So what is the conclusion? So here is the conclusion. Let me underline it for you. You can also underline in your textbook. So finally, what we have concluded is that particles of, and this, let me write, this is conclusion number 1. Particles of matter are continuously moving. That is, they possess what we call as the kinetic energy, right? Point number 2 of conclusion, as the temperature rises, particles move faster. So we can say that that with increasing temperature, the kinetic energy of the particles, let us make it point number 3. So there are 3 conclusions or 3 pointer conclusions which we can draw is that particles are continuously moving. As the temperature rises, the movement increases. So finally, what we can conclude is that kinetic energy is directly proportional to temperature. More the temperature, more will be the kinetic energy. So I hope till here you all are clear. Now let us go to the next activity. Now let's see what is the heading of this activity. Particles of matter attract each other. Now this is activity 1.6. It's a very common activity which teachers love to do in the class when they want to demonstrate the attraction between solids, liquids, and gases. Now here you can make in the class also, you can make 4 groups, like play this game, make 4 groups. And so you can take children or ask children to make 4 groups. In the first group, they should hold each other from the back as there's a dance in one of the states. Idu Mishimi dancers. So they lock their arms. Okay, this is the first group. The second group should hold hands and form a human chain. The third group should form a chain by touching each other with their fingertips. And what is fourth group supposed to do? So it has to run around those 3 groups and try to break the human chain or the 3 groups one by one. Right. Which group was easiest to break and why? So it is but obvious that those groups or that group which were touching each other with their fingertips is the most easy group to be broken. Right. So if we consider each student as particle of matter, then which group of the particles held each other with the maximum force? So the one which were holding or locking arms were representing the particles of solid. The ones which were holding hands, they were representing liquid. And the ones who were touching each other with fingertips were the particles for representing the particles of gases. So who can be easily broken? Gases. So who has minimum force? Gases have minimum force of attraction and solids have maximum force of attraction. So this is what is being proved in this particular activity 1.6. Now activity 1.7. Here this activity proves it has taken three types of solid: iron nail, piece of chalk, and rubber band. All three are solids. But then depending upon the nature of the solid, also the force of attraction differs. So now how have we proved, or how do we proceed in this activity? Try breaking them by hammering, cutting, and stretching. So you have to hammer or cut or stretch an iron nail, a piece of chalk, and a rubber band. In which of these three substances do you think the particles are held together with greater force? So it is but obvious that iron nail has the strongest force of attraction and rubber band has the weakest force of attraction, even though all three are solids. So one is that solids, liquids, and gases comparison of intermolecular force of attraction. Then next is that even solids also, they differ in their force of attraction depending upon the nature of that particular solid. Now activity 1.8, take some water in a container, try cutting the surface of water with your fingers. Were you able to cut the surface of water? So yes, if you try to move the knife through water, the knife will move easily. So compare the movement of knife through water and let's say through apple. So you can very easily figure out that through water the knife moves more smoothly. Similarly, you can keep butter also in the center. So first is the hardest one is apple, then you have butter, then you have water. Were you able to cut the surface of water? Yes. What could be the reason behind the surface of water remaining together? So very good question over here. So although you move your knife through water, but still then water becomes one, or it becomes the original, it comes in the original form and shape. So what is bringing them together? So intermolecular, here again, the answer is intermolecular forces. So although you cut through the particles, but then the intermolecular forces bring them together. So what is the conclusion of all these activities? So about three activities, 1.6, 1.7, and 1.8, suggest that particles of matter have forces acting between them. This force keeps the particles together. The strength of this force or attraction varies from one kind of matter to another. So I hope you all are clear till here. Now let us go further. Now we have some questions based on whatever we have learned till now. Let's try these questions. Question number 1. Which of the following are matter? Now first, children, you have to think that what was the definition of matter. So the definition of matter was anything which has mass and which occupies space. So let us test one by one. Chair, it has mass and it occupies space. So let me put a tick mark on chair that yes, it's a matter. Air, yes, if you fill a balloon with air, it will occupy space. It has mass, so air also is matter. Love, hate, and thought, and cold, these are feelings. So feelings and energy, these type of things, they don't have any mass. Yes, they weigh upon us. Like if we are sad, it weighs upon us, but sadness does not come in the category of matter. It does not have mass and space. Okay, so these are not matter. Smell is a bit dicey, but smell does travel through air. Although smell is a sensation, so let me underline smell also. So love, smell, hate, thought, cold, they will not come under the category of matter because they don't have mass and they don't occupy space. In abstract manner, yes, they occupy space and they weigh upon us. Almonds, yes, they have mass, they do occupy space. Lemon water has mass. Smell of perfume, again, when perfume comes into the picture, then it's a matter. Small particles, they are traveling through air. So smell of perfume, I'll put a tick mark. So finally, to make it more clear, let me tick mark the matter, the things which come under the category of matter. One is air, then almonds, then lemon water, and the smell of perfume. So they come under the category of matter. Give reasons for the following observations. The smell of hot sizzling food reaches you several meters away, but to get the smell from cold food, you have to go close. Now here you will connect it to the kinetic energy of particles. So kinetic energy of particles, if you remember, I wrote that kinetic energy of particles is directly proportional to temperature. So hot food, more kinetic energy, so it travels far off, and cold food, less kinetic energy. So you have to go closer to get the smell, as direct as it can be. Third, a diver is able to cut through water in a swimming pool. So first is done, second is done. Which property of matter does this observation show? A diver is able to cut through the water in the swimming pool. So cut through, so the property with which it is attached is interparticle spaces. Interparticle spaces. As we know that the spaces are more in liquids as compared to solids. So that is why a diver is able to move easily through water, because water is a liquid and liquids have more interparticle spaces as compared to solids. What are the characteristics of particles of matter? So we till now we have studied that particles of matter are very small, they continuously move, they have spaces between them, and they have force of attraction between them. Force of attraction. So these can be considered as the characteristics or properties of matter. Is there any other question? Let's see the next page. So let me scroll down. Fourth question, yes. So so 4 questions we have discussed, all the 4 questions. I hope you are getting a clear picture of the activities and what this chapter is trying to tell you. In the chat box, children, you can write if I did not address any query, or if you still have any doubt, you can in the chat box very well uh, pose a question. So I will definitely get back to you and answer that. Thank you for being with me. Thank you so much. Goodbye. See you again. Bye-bye.